There's all kinds of different enthalpies that you'll find, right? Usually they have different subscripts. So if you notice in the last video's combustion, there was a C down here. There's an F down here. So this is the standard enthalpy of formation. And the subscripts don't matter too much. They just give you a little bit more detail about what's being talked about. The reason that it's called standard is because we're at these standard states. Again, pressures, about 1 bar or 1 atmosphere, temperature about 25 degrees Celsius. If you have solutions, it'd be 1 molar. In terms of these delta H of formations, they're always written to form 1 mole of product. And everything is always in its pure elemental form, or always form from the pure elemental form. So for example, if we wanted to look up the standard enthalpy of formation of nitrogen dioxide as a gas, what we would do is combine it from its pure elemental form. So we'd combine it from nitrogen. But we'd only need 1 nitrogen, and nitrogen exists as N2. So we just grab half an N2 plus an O2. And then if you looked at this delta H formation, you get a positive 33.2 kilojoules, right? So it takes energy to form NO2 from its constituent particles, right? And then you could do other stoichiometry, right? What if you wanted to know the standard or the enthalpy of formation of 2 moles of NO2? Right, it's just standard stoichiometry, right? Start off with what you're given, 2 moles of NO2, and then use your conversion factors, which this is in the equation, right? So for every 1 mole of NO2, we need 33.2 kilojoules of energy. That cancels out, you get 66.4 kilojoules, right? And same thing, instead of talking about moles, I could talk about grams instead. And then you just have to do an extra step of converting the grams into moles using the molar masses. So again, this is just more stoichiometry. It's not going away. It's going to be here. Make sure that you have a good foundation. And if you don't, you want to fix that up pretty quickly. Right, so convert my grams into moles, then convert my moles into kilojoules. I end up with 1.4 kilojoules, right? Another thing that we notice is that all of these values are positive. So all of these are endothermic. Right, they're going to absorb heat, absorb energy, that kind of thing. Not too much to say about this.